Hey everyone. So this week's lecture is about rivers. And so we are going to focus on understanding the importance of rivers, diagnosing their major characteristics and dynamics, and then talking about the two main different stream and channel classifications. So far in this class, this semester, we've been focusing on the geosphere, right? So of the Earth's four spheres, we've largely in this first third or fourth of the semester focused on the geosphere, right? We've been talking about rocks and minerals and volcanoes and earthquakes and plate tectonics. And now we're going to move into talking about the hydrologic cycle, right? So we're going to move into talking about the hydrosphere. So this week we're going to be talking about rivers, which are part of the hydrosphere. Then we will be talking about some groundwater. We're going to be talking about oceans. We're going to be talking about glaciers, snow and ice. We'll be talking about precipitation and weather. And so during this next fourth of the semester, we'll be talking largely about the hydrosphere, and we're starting off that conversation by talking about rivers today. And so stream runoff is an important component of the hydrological cycle. Remember, the hydrologic cycle or the water cycle is just how water moves around the hydrosphere. And remember that the hydrosphere interacts with the geosphere, the atmosphere, and the biosphere in different ways. All right, so running water is really important when we're thinking about interactions with the geosphere because it's an important erosion agent, right? It's a really important way to move things around the Earth's both around the Earth's surface and through the atmosphere and through the ground. And so a river system, or we can also think of a river system as a drainage basin. And so a river system is just a network of connecting channels through which water that has been precipitated onto the continents is collected and funneled back into the ocean, right? So if you're thinking about the largest mass of water on Earth's surface is in the ocean. Sometimes we evaporate that water out of the ocean, precipitate it onto the continents, and then that water eventually is going to run downhill back into the ocean. And as I mentioned, running water is by far the most important erosion agent. So when we're thinking about creating sediments and moving nutrients around the Earth's surface, running water is by far the most important agent that moves those around the Earth's surface. A couple of definitions for you to know. A drainage basin is the area of land that is drained by a certain river system. And a drainage divide is the boundary that separates one drainage basin from another, right? So here we have a drainage basin shown in this darker green. And then you can see that everything within that drainage basin eventually flows down into this stream. And then our drainage divide, if you drop a drop of water there on the drainage divide, right, it will either go into this drainage basin or into the drainage basin over here, right? So the divide is the boundary between two drainage basins. All right, so let's talk a little bit about stream flow and the dynamics of stream flow. So rivers and streams are highly complex systems that are influenced by lots and lots of variables. And we actually have 6 really important variables to determining the type of stream that you're going to have, right? So the type of stream that you have, how much it and how it looks, right? And how much water it transports, and the type of materials that it transports are related to these 6 variables: discharge, gradient, velocity, flow, sediment load, and base level. And so I'll talk about each one of those in turn. Discharge, when we're talking about discharge of a river, the definition is the amount of water passing through a given point during a specific interval of time, right? So discharge is just a measurement of the amount of water that has passed a certain point in a river over a certain amount of time. And discharge is measured using something called a gauging station. And so you've maybe seen gauging stations on major rivers, maybe on the river that flows through Defiance, or that you've seen while you've been out and about. So gauging stations measure discharge by having recording equipment in sort of a little hut, and they have a valve in here that measures essentially the amount of water that's passing through the station over a certain amount of time. And usually a discharge measurement is in cubic feet per second, right? So the amount of water would be measured as cubic feet, and the interval of time would be seconds. The second important factor for determining what a stream looks like is what we call stream gradient, which is essentially just the slope of the stream channel. And so this is the change in elevation divided by the distance, right? So think of how you calculate slope in trigonometry class, right? So we think about here's our stream profile, right? If we're looking at our stream from the side, we have a change in elevation over a certain distance. So if we divide that change in elevation by our distance, then we get the gradient. And the steeper the gradient, typically you're going to have a different type of flow than if you have a slope that is not as steep, right? If you have a gentle slope, we end up getting a certain type of river channel. And if we have a steeper gradient, we end up getting another type of stream channel. And we'll talk about those channels here at the end of the lecture. The next important variable to determining the properties of a stream is water velocity. And so water velocity varies both with stream gradient, right? If you have a higher, steeper gradient, you're going to get a faster velocity just because if you have a higher gradient, then you're going to be increasing the force of gravity on that water. And we can also have velocity changes within a channel. And again, we'll talk about how velocity changes within a channel when we talk about the two main classifications of rivers and streams. Flow is a fancy way to talk about how a fluid behaves. And so the flow of a fluid depends on how fast it's moving, right? Its velocity, the depth of the flow in the river, and the viscosity of the fluid. And there's two main types of flow. We have something called laminar flow, and we have something called turbulent flow. And so laminar flow is when we have independent streams, they are not interacting with each other. It's relatively rare. Usually what we have is turbulent flow, which is the fluid behavior sort of interacting and creating these little eddies, right? It's not perfect flow. They're sort of interacting with each other, not traveling in straight lines. So this video shows the difference between laminar and turbulent flow. So we can see how laminar flow, everything's flowing gently in a straight line. And then they put this little corkscrew in here to make this turbulent. And you can see how this water is not as clear. It's interacting with more within those individual streams. The next important factor for determining what a stream is going to look like is the sediment load. So flowing water is something that can pick up and transport sediment. Right, so remember, sediment is just pieces of rocks. We can also sometimes refer to sediment as regolith. So it kind of depends on if you're coming at it from a geologist standpoint, who somewhat you might use sediment in that case, or if you're coming from more like of a soils standpoint, like engineering standpoint, then you might use the word regolith, right? So flowing water can pick up and transport loose rocks and loose material, and we can actually transport that sediment 3 ways in a stream. And those 3 ways are suspended load, bed load, and dissolved load. So suspended load is particles that are light enough to be held up in the water column as they travel through the river. So these are going to be more of your clay, silt-sized particles. And then your bed load is going to be all of the heavy stuff, right? So it's too heavy to be held up in the water column, but it kind of moves and rolls down along the bottom of the river, right? So think of larger pebbles, right? Gravel, sand, those things that when you're walking in a riverbed, you feel on your feet. So this sometimes includes those smaller mud and mud, clay, silt-sized particles as well. And then the dissolved load, remember when we were talking about sedimentary rocks, and we have this whole class of biochemical and chemical where we have water with dissolved ions in it, and then those dissolved ions come together and create a rock and create a solid. This dissolved load would be those ions that have been eroded away through chemical processes. And so anytime you have any dissolved ions in water, we would refer to those as the dissolved load. So here's a diagram showing what our suspended load looks like. Those are our small particles. Our bed load's down here rolling, jumping along the bottom. It's too heavy to be carried in the water. And then our dissolved load are those ions that we can't see, but we call them carried dissolved, right? They're invisible in the form of chemical ions. And then base level is also important to determining what a stream is going to look like. And the base level is just a fancy way to say the level to which a stream will erode. And so base level, the ultimate base level is sea level, right? So at an elevation of 0 where the ocean is. All rivers eventually lead to the ocean. So our ultimate base level is the ocean. We sometimes also have localized base levels, like if we have large lake systems, like the Great Lakes, that would be a local base level, where streams are going to erode down to that base level. And as they get closer and closer to base level, the velocity of the stream actually decreases. And so as you decrease your velocity, the energy of the stream decreases. And as you decrease energy, you decrease the ability to erode, right? So streams with lots of velocity can erode a lot of stuff. So far away from base level, you're going to have lots of erosion. And as you get closer and closer, you're going to have less and less erosion. All right, so go ahead and go back and review those 6 important variables for the dynamics of stream flow. And then once you've reviewed, of course, you can pause and go back and look those over. We're going to now talk about the types of stream channels. And so we classify streams into 2 main types: meandering streams and braided streams. So meandering streams, these are largely what we have in this part of the US, and they're sort of those loopy, wandering, curvy streams. And so what happens with a meandering stream is that streams, instead of carrying their sediment wide, what they do is they have a lot of velocity in a small channel. And as they move through the channel, what happens is we get deposition on the inside of banks and erosion on the outside of banks. And as we deposit on the inside of banks and erode on the outside of banks, we get what we call a cut bank on the erosion side and a point bar on the deposition side. And as we continue this, cutting away one side, building up another side, cutting away one side, building up another side, over time, right? Cutting away on the outside, depositing on the inside, we get this curvier and curvier and curvier river until eventually, rivers always want to take the path of least resistance. So what eventually happens is that this curve becomes harder than it would be just to cut straight across here. And so we sort of cut off this limb of a river and we create an oxbow lake. So there's tons and tons of oxbow lakes across the Midwest from these meandering streams that we have. So we have turbulent flow in meandering streams and velocity changes where we have higher velocity on the outsides on our cut banks and lower velocity on the insides mean that we erode on the outer banks where we have higher velocity on the insides. On the inner banks where we have lower velocity, we're going to deposit material. Here's just a diagram type video of how a meandering stream might develop through time. See that channel's getting wider and wider as it erodes and gets wider and wider and curvier and curvier. All right, so some characteristics you need to know about meandering streams. In our meandering streams, we have a fine sediment load. So the sediment in a meandering stream is dominated by that suspended load, right? So finer sized particles, clay sized particles, and silt sized particles, those ones that could be carried in the water column, those are going to be dominating our meandering streams. They have a relatively steady rate of discharge. So all throughout the year, they have about the same amount of discharge. There might be like a low season and a high season, but for the most part, relatively same amount of water moving through the system. These are found on our low gradients. So places where elevation change isn't very big. The clay banks of meandering streams, right? So these are largely based in places where we have lots of clay making up our soils. Because we have clay banks that are hard to erode, that means that the channels are confined. And so instead of spreading really wide to carry all that energy is used to erode away the outer bank and deposit on the inner bank. Right, so these streams don't spread laterally to carry their sediment load. Instead, they erode away the banks and become curvier and curvier. Okay, so here's a really cool satellite image of the Mississippi River, which is a meandering stream. You can see some of these old meander bins that have been abandoned for a different route. All right, so we have meandering streams as one classification. The other classification is braided streams. And braided streams are a river that has multiple channels, right? So our meandering streams largely have one channel. In our braided streams, there's multiple channels, and they're called braided, just like you have multiple pieces that you braid together when you make a braid. Same idea, you have multiple channels that are braided or woven together. So the channels are actually interlaced, and in between those, we have islands, which are called sandbars. So sometimes we do get a little bit of braided streaming happening in this part of the Midwest. It's not as common, but out in mountains, there's a ton of braided streams out on the plains. So think of in Kansas, Nebraska, North, South Dakota. There's tons of braided streams out there. And so characteristics of braided streams are these streams have a coarse sediment load, so largely dominated by bed load, sand-sized particles, lots and lots of sand being carried, and bigger particles being carried in these streams. And braided streams have a more highly variable discharge, where there could be a season where you have really, really high discharge and another season where you have really low or almost even like a dried out river. And so discharge is fairly constant in our meandering streams, but in our braided streams, it's more variable, right? It's not as constant. We find braided streams in places that have a steeper gradient, right? So where elevation change is higher, then this is where we find braided streams. So think of in the mountains or at the base of mountains on the plains where we have a higher gradient. That's where we're going to find braided streams. And the banks of braided streams are really easy to erode. And so unlike meandering streams where they have hard to erode banks, braided streams can easily erode the banks away. And so the channels migrate and move around quite a bit. And so streams largely have lots of bed load, and they can carry it all through spreading laterally because they can easily erode their banks, and so they're able to spread laterally. And then the last thing I want to focus on as we're sort of getting the lowdown on rivers is floods. So the definition of flooding is the overflow of water from a stream channel onto adjacent land, which is usually dry. And when we're thinking about floods, typically these are going to be occurring seasonally, and we classify or talk about floods based on something called a flood recurrence interval. So flood recurrence intervals are based on a probability. So maybe you've heard of something called like a 100-year flood. And so because flood recurrence intervals are based on probability, if someone says, oh, this is a 100-year flood, that means that it is likely to occur once every 100 years on average. So it means that every year there's a 1 in 100 chance of it occurring. But that means there's a 1% chance of it occurring in any given year. And so maybe we have a 100-year flood this year. There's still a probability that we could have a 100-year flood next year. It doesn't mean that it only happens every 100 years, right? So there's a 1% chance that a flood of that magnitude will occur every year. But it does not mean that the flood will occur on the dot, right, like it's scheduled every 100 years. Right? We could have a 100-year flood this year and a 100-year flood next year, right? It's just based on a probability and based on statistics. But think of it more of it as a percent chance of occurring than using that on average number.